This next proof is dealing with a segment. So the last ones we've been dealing with were angles. So first they gave us AC equals BD, so remember that's always going to go in that first step. So I rewrote that statement and then I'm writing in what they are given. Now I'm trying to come up with, come up with the reasons for why they filled in that left side. So they have AC equaling AB plus BC. So remember in chapter 1, if I have a big, I can chop that into two smalls to add together to equal that one big. And you have to be aware that this is why proofs start to become a little challenging, because you have to utilize everything that we've been taught. So we have done problems where we've solved it, but I don't know if you remember what it's called, and it's called a segment addition postulate. So then notice that BD is a big and it's chopped into two smalls that we're adding together. So it also, the third statement would also be segment addition postulate. Now I want you to kind of think to yourself, why did they go AB plus BC equals BC plus CD? What did they do? And this is where you also have to understand that it's not always looking at the previous step to figure out how they got down here. It might be backtracked a couple steps, or it might just be two of the previous steps. So you have to make sure you take in consideration of everything that you've done so far. So I want you to go back up to these two and notice that this matches here, and notice that this matches there. So trying to figure out how does these two connect possibly with this, because we haven't used the given at all, and there's a reason why they gave that to us. So I want you to notice that if AC is this section, I would be able to substitute that on this side of the equation for AC. Same thing for if BD equals this section, I would be able to plug that into BD on that side of the equation. So with that being said, they substituted and used the substitution property to come up with this equation. They used these two previous steps along with the third previous step to come up with this statement. Now trying to figure out, well, how did I go from here to here? Well, I see the AB, I see the CD, I notice that the BCs are gone, so I'm thinking in terms of an equation, how did they get rid of it? Well, since that's a plus sign, they went ahead and just subtracted from both sides to get rid of that BC. So the reason I wanted to show you this proof is for two reasons. One, to show you that segment addition postulate starts to be used quite a bit. Two, you're not always looking at the previous step. You could always sometimes be looking at a combination of previous steps. If you've not used the given yet, you need to be using it at some point. So I always want to keep that in the back of your mind, because you will use it at some point. Okay, I want you to pause the video and try doing the next example. So on the next one, the first step you should have is given, so hopefully you got that far. Next thing I'm looking at is BC equals BC. Well, I notice it's the same thing on both sides, so I know that's going to be the reflexive property. Then I'm going to see AB plus BC equals BC plus CD. I'm trying to utilize these pieces from the previous step. What I notice is that I've taken this equation and I added BC to both sides of that equation. So to me, I know that's going to be the addition property because I'm just adding that BC. Then I'm trying to figure out how I came up with this. So I look at what AC is, and I see that it's AB plus BC. That's going to be, again, that segment addition postulate. Then I see they give me BD is equal to BC plus CD, and again, that's a segment addition postulate. So then at last I'm trying to figure out, well, how do I go from here? Well, notice that this expression is the same as here, so I could substitute AC in that spot, and notice that BC plus CD is the same as this expression, so I could plug BD in that spot. So that last one would be substitution property. Now, these are more challenging because of the fact there's no numbers in there. You're starting to see that you can use some of the previous steps in order to do it. So I do want you to try one more proof, and that one more proof is the last one that's on your note-taking guide. So if you would go over there and see if you can finish that proof and then come back to me. Okay, so first make sure that you have your proof statement. I think I fixed that, but I'm not sure. The first step you should have, so make sure you have the given, and then the prove you should always have at the bottom. So if nothing else, you had that part. Now I'm looking at this first step. It says that that ray bisects this, so the important word is bisect. So if it's bisecting it, I know that these two angles are now going to be congruent. So that's why I wrote the measure of angle RAB has to be equal to the measure of angle BAN, and that's a definition of an angle bisector. Now I'm going to take these two and plug in their expression. So x is going to plug in for ARB, and then the 2x minus 75 is going to plug in for the BAN. That's your substitution property. Then I'm going to start doing my solving. So I'm going to minus 2x over, which is the subtraction property, and then last I'm going to divide by -1, so I have division property. So point being is that your proofs will be somewhat guided for the rest of this chapter in 2.5 and 2.6, but I want you to see that in this last proof, this is where we're going. So eventually you will not be given this stuff, and you'll have to figure out how to put that stuff in there.